So this sum is to remove k digits and given a string num representing a non-negative integer num and an integer k, we have to return the smallest possible integer after removing k digits from num. So what it means is that we have a number given, like a number in a string, okay? So it's basically a string and a string containing digits, for example 1432219, and k is given as 3. Okay, so what it means is that we have to remove 3 digits from our string, and then such that our existing leftover numbers are the number is the smallest. Okay, so from this, if we remove the 3 digits 4, 3 and 2, we can form the new number 1219, which is the smallest. Similarly, over here, if we have to remove one number, and here we will remove, what are we going to remove here? We're going to remove 1, and the leading, that is the 0 before the 2, will not be, the output will not contain that 0. Okay, so here we need to remove two digits, so we just remove 1 and 0. So we remove all the digits from the number and it's left with nothing, which is 0. So how do we do this? For example, we have the string 143729 and k is equal to 2, right? So we have to remove 2 digits from here such that the number will actually be very small. So we have this is our output 1329. So it will be 1329. We are going to remove 4 and 7 so that it becomes the smallest number. If you remove if we remove 3, we get 1 4 something. So that is obviously greater than 1329. So we have to see the peak and the drops. Okay, so the peak and the dips, as they call it. If there's a peak, then we have to remove it. I mean, if there's a dip, we have to remove that element that the peak, that a number before the dip comes, that which is the peak. So we see that 4 is greater than 3, and so we have to get rid of this 4. And similarly over here, there's another dip over here from 7 to 2. So it goes downhill, right? From 4 to 3, it goes downhill. From 7 to 2, it goes downhill. So we're just going to remove 4 and 5, and that we are left over with 1329. Supposing we have to remove 3 elements, then what are we supposed to do? We get 1, 2, and 9. So we see that we have to remove 3 as well in the second case where k is equal to 3. Right, because once we remove 4 and 7, there'll be a dip between 3 and 2. So we are going to remove 3, so we are left with 129. Right. So we can also use the intuition method, wherein we just, for example, there are 4 numbers, right? There are 4 digits inside the string, and we have to see what could be the permutations combinations. So it will be 4 factorial, and we have to always arrange it in ascending order. So that means 2, 3, 4, 5. So it's always in ascending order, and then we have to see that the most significant bit, that is this bit over here, right here, that is the leftmost bit, is the most significant bit, and it should obviously contain the lowest value. So it's containing 2 over here, and this one is containing 5. What if suppose this contains 5 and this contains 2? That will be very large. So we have to keep in mind is that we have to arrange it in ascending order, and most significant bit should be the digit should be the least value. And we cannot juggle the digits as well, right? We cannot, for example, here that we have 1437. We cannot juggle the digits like one. It's only in the same order as in the string 1329. We cannot just write 1239. Even though the digits are there, we cannot interchange 2 and 3 and write 1239. We have to um, we have to make sure that we have to ensure that we are following the same order. So suppose we have a case over here without any zeros, right? In this string, there's no 0 present here, and we have to remove 2 elements. K is equal to 2. So the most significant has the most weightage, right? So this one has the most weightage over here, and so if k is equal to 1, we get 37211. Do we get that? Yeah, we have to remove one element, so we're just gonna remove this R8, right? We will remove our 8 and we get this. But then this is not really very big actually. It's very big, right? But we are supposed to have a smaller number. So we could obtain a smaller number by removing 7 rather than 8. So we shouldn't actually remove 8. 8 should not be removed, but rather 7 should be removed. And why is this? Because even though 7 is a more smaller number than 8 and 8 is a bigger number, our intuition may think that we have to remove this bigger number so that this one becomes small. But no, so, this index position, right? This position has more weightage than this position. So we have to make sure that this one containing the most value and worth, as I call it, containing the most value as the most weightage. You have to remove this 7. Only then we can get our correct answer, which is 32181. Suppose k is equal to 2 means then we have to remove 3 over here. We still shouldn't remove our 8. So we have to remove 3 because that contains the most significant bit, that also contains more weightage. So our answer will be this. Supposing we have a case where there are actually zeros present inside our string, then there's 1 2 3 0 9 8 7. So there's a 0 present in the fourth index. Sorry, 0 1 2 3 third index. So k is equal to 3. So we have to remove 3 digits from our string. So we have to look into the concept of peak and dip. So what is peak here and what is dip here? First we have to see that 3 is a peak element because before 0 it's coming, and from 3 to 0 we see that it's a dip, right? We are going downhill, so we have to remove this 3 obviously. And then after that, after 3 is removed, we have 2 and 0. So obviously from 2 to 0 it's going in a dip, so we have to remove 2 as well. So we are left with 10987. Right. So yes, so that will be the least element. Suppose k is equal to 3 means we have to remove 3 because it's going in a dip, it's going in a downhill, then 2. Then finally we have to remove 1 as well because it is the most significant bit and it has the most weightage. And then we will just return this number, that is 0987. But 0 has to be ignored. It should only print 987. So that is the concept. So we need to leave the leading zeros. So another example we have over here, 143 01620. So this is our string, and suppose k is equal to 4, we have to remove 4 elements. So we will put it inside a stack. We use a stack data structure for this. So we are just inserting all our elements 143 162, right? So once we are we're pushing it into our stack, you have to see that if there's a dip or not. So from 1 to 4 we see that, do we have a dip? No, it's actually a rise, right? It's actually a rise. From 1 to 4 it's no dip, and from 4 to 3 there's a dip, right? So we have to remove 4, like that. So we need to pop 4 from our stack. So whenever we encounter a dip, then we have to pop that element that comes before the dip, right? So we have popped out 6 as well because after 6 there's a dip. So the thing goes on like that. So now we have to compare with the topmost element. So after that we are pushing 3 after we remove 4, right? So we're pushing 3 and 1, and then after we push an element, we have to decrement the k value because for each iteration these two steps need to be followed. So now p is the 3 is the peak element, right? 3 is over here, and now that is a peak element. And then because we are comparing 3 and 1, so that will be the peak element, so we will remove our 3 as well. So 3 is also gone now from the stack. We'll pop it out. Then we will remove 1 and 6. Yeah, 1, we're going to remove 1, and we will just also remove the 6. Then what are we left with actually? So whatever it is left, we have to pop it out. So after removing all those elements, we will pop that out. So we will just get, okay, our example is 143 162. So our answer will be whatever is left of this stack after we pop everything out. So we have to push that 3, and then simultaneously we need to decrement the k value as well. So here we have to keep on removing or popping out one element after the other, and by doing that we will just whatever is left we can just pop it out. So it's order of n time complexity because we are iterating through once, and order of n space complexity because we're using a stack over here. Suppose the string is given as 1 2 3 and it's an increasing order. So what we have to do is we have to remove the last two elements because this is the most significant bit. So suppose we have to remove two elements, we remove those two elements. Suppose it's 1 0 0 1, then we have to remove two elements, so we remove this one and this one, and we have to 0. So we have to return 0. And coding this, we can see that we have taken we take n int n, so that will be the size of our number. Then we will take a stack containing characters and it's named as my stack. And for iterating through each character, right, inside our num, right, num is our string and each character, that is c. Then we are checking for something. We're checking whether a stack is not empty and k is greater than 0, and stack dot top of this, whatever is present on the top of the stack is greater than c, is greater than the character. Then suppose it is greater than the character, then we have to pop it out, and we need to decrement that one value as I told before. We have to pop that element, remove it, and then decrement the k value by 1. And then suppose the stack is empty and c is also not equal to 0, then what you have to do is you have to push that C, you have to push that character inside a stack. So those are the two operations we need to do. So and this is for storing the final string in the stack, right? And then now what you have to do here in this while loop is, now we have to remove the largest values from the top of the stack. So whatever the largest values are present on the top of the stack, we have to pop it out, right? And after popping it out, the stack is not empty, and we decrement the k. right? And then we pop it out. If my stack got empty off, if the stack is actually empty, then we return 0. Then we have to the next while loop. What it says is that we have to now retrieve the number, this while loop, from the stack into a string. So we have to retrieve this number from the stack. The number is currently present inside a stack, but from the stack we have to take it out, and then we have to make it in the form of a string. So that's what we're doing here. If the stack is not empty, we're just going to pop all the elements from the stack, and then we will just decrement it n by 1, and then finally we will return the substring. So that's it. We can just run our code and see, and it has passed.